Hi there, thanks for joining me again. This video will focus on solving quadratic equations using the graphic method. And in this playlist, if you haven't gone through the entire playlist for quadratic equations, please check it out. There are a few other ways of solving quadratic equations and they each have their own video. But here we will be solving them graphically, and that's kind of similar to solving linear equations graphically. What we're doing is we're looking for the zeros of a quadratic function, or the places where the quadratic function crosses the x-axis. So in this graph here on the right, we have a few quadratic functions, a few parabolas, and we're looking for the places where they cross the x-axis, or where y equals 0 for a function. So as a reminder, a general quadratic function is given by y equals ax squared plus bx plus c. And when we want to find the solution to the equation ax squared plus bx plus c equals 0, we're looking for the place where x gives us y equals 0, right? Y equals 0. Where is y equals 0? Y is equal to 0 right there, all along this x-axis, which I actually emphasized in green. So let's keep it green here. So on the x-axis is where y is equal to 0. And so if we look at the quadratic function, we can draw it and look for the places where the quadratic function crosses the x-axis. So let's make this neat again so that it's easy for us to follow along. Now, what's interesting about quadratic equations is that we can get more than one solution. Specifically, we can get up to 2 solutions for a quadratic equation that has as its highest power of x squared, like here. So I have 3 examples here, and we'll go through at least 1 or 2 of them in detail. But each example will show a different scenario in terms of the quadratic function. So let's start by looking at this red one. We have here x squared plus 5x plus 4 equals 0. This is our first equation. And so if we write y equals x squared plus 5x plus 4, we're looking for x's that will give us y equals 0. And the way we do it is we just draw the graph of the function, and then when we interpolate it, which means when we fill in the line between the points, we will find where the line actually crosses the x-axis. So we can actually make a little table here, right? We could do a table x and y and looks at different values of x and use those to start graphing our function. So for instance, for x equals 0, we have y equals 0 squared plus 0 plus 4. So y equals 4. So 0 and 4 is this point right here, right? X equals 0 and y equals 4. Let's look at x equals 1. We have 1 squared plus 5. So that's 6 plus 4. That's already 10. Okay, so for x equals 1, we go straight up here to y equals 10. Let's look at x equals negative 1. What do we have at negative 1? Negative 1 is squared is 1, plus 5 times negative 1, which is negative 4. So we get negative 4 plus 4, it's exactly 0. So in this case, it's actually quite simple. We actually got one of the points that solves this equation because it's right there on the x-axis. Let's take negative 2. Negative 2 will give us negative 2 squared is 4, plus 5 times negative 2, which is minus 10. So 4 minus 10 is minus 6. Plus 4 is just also negative 2. So negative 2 right there, all the way down to negative 2 is here. And let's do a couple more points. Let's do -3. -3 squared is 9. 5 times -3 is -15, right? -15, so 9 minus 15 is -6. Plus 4 is again -2, right? So we're right here. And finally, let's do -5. Let's do -5. So -5 squared is 25. 5 times -5 is -25. So we have 25 minus 25 is just 0. And so our y is 4. And -5, which is right here, we go up there. Okay, so now we can estimate our parabola by taking a line, a curve, right, and trying to go through our points. So we can go through -1 and 0, around, and really I'm just tracing the curve that was already there because I knew I wouldn't be doing a great job with drawing this curve. But as you see, now by drawing through this curve, I also got my second solution, which is at x equals -4. So we have -4 and 0 as one point, and the other is 1 and 0 here. So our solutions are x equals -4 and +1. So those are our solutions just from graphing this function. Of course, I did cheat here because I had the curve drawn already by Desmos, but it helps to see how this works. Let's move on to our next example, which is here in blue. Here we have -x squared plus 2x minus 1 equals 0. So we're looking at the zeros of the function y equals -x squared plus 2x minus 1. Okay, so here we have a negative coefficient for our x squared term. Our a is equal to -1, and therefore we know that we'll have an upside down parabola, right? It's going to open downwards. But again, we're looking for the places where the graph actually crosses the x-axis, where y equals 0. So let's do the same thing. Let's make a little table here, x and y. And again, we always start with x equals 0 because that's sort of easy. When x equals 0, x squared is 0, 2x is 0, so y equals -1. And we are right here. I'll make a kind of large point there. Let's go to x equals 1. At x equals 1, we have -1 squared plus 2 times 1. So that's +1 minus 1. And we hit the 0. So again, we hit a point where the curve, the graph of the function, crosses or touches the x-axis. Let's look at x equals 2. Well, when x equals 2, we have -4 for our first term, plus 4, so that's 0, minus 1, so it's -1 at 2 right there. And we can go on. Let's do 3. -3 squared is -9, plus 2 times 3 is 6, so we get -3, minus 1 is just -4. So 3 is now at -4, okay, right? You see that here and here. And we can look also at, let's look at x equals -2. And in that case, -2 squared is 4. So we have -4 for our first term, plus 2 times -2, which is another -4. So we have -8. Minus 1 is just -9. So -2 here, we go all the way down to -9. And again, we can draw a curve through our points here. And what we find in this case is that the graph of the quadratic function touches the x-axis in just one point. It doesn't quite cross it, it just touches it. So in this case, we only have one solution. We have the solution x equals 1, right? 1, 0 here. So x equals 1. So in this case, we have just one root. We also call the solutions of a quadratic equation roots. So we have one root here. And in the previous example, we had two roots. We had two solutions, right? Because the parabola actually crossed and went below the line here. Okay, so now we have one more example, and in order to go through it, I will do some erasing here so that we can actually see what we're doing. So in this case, we're looking at this black example here, the graph in black here, and you can tell that there's something interesting about this graph that's different, and that it's not actually crossing the x-axis. So what does that mean? Well, if we draw a graph of this quadratic function, y equals x squared minus 5x plus 7, what we find is that it never actually crosses the x-axis. Y is always greater than 0. Not greater or equal, but it's always greater than 0, no matter what x we try. And therefore, we get all these points above the x-axis, never crossing, and so we have no roots. Okay, and it's enough to just start with, say, if we would start with x equals 0, and again we get plus 7 here, and then we can try x equals 1. When x equals 1, we have 1 squared minus 5, that's minus 4, plus 7, so that's 3. We get 3 here. Then we can look at x equals 2, which 2 squared is 4. 4 minus 5 times 2 is 4 minus 10, so that's negative 6, plus 7 is just 1. Then we go to 3, and what do we get? 3 squared is 9. 9 minus 5 times 3 is 9 minus 15. Again, that's negative 6, plus 7 is exactly 1 again. And so we go on. If we go to 4, we'll find that our y value is 3 again. And what we learn is that when we draw the curve, we can't get it to go below the x-axis or below the point where y equals 0. And so in this case, we have no roots, and our equation has no solutions. One way to do this is by completing the square for x squared minus 5x and finding that the square of the expression is less than 0. And then we can't find actual roots. And you can see that in using the method of completing the square, which is given in a different video. But the important thing is that even graphically, we can see that we don't have solutions in this case. So thanks for joining me again. If you haven't seen the other videos about the other methods for solving quadratic equations, please check those out, because the graphical method is really the most labor intensive, and usually it's easier to just solve with the other methods. So check those out. If this was helpful, please hit that like button and join me for the next video.